DSLR camera.
Hello, everyone. Welcome to the class. Can you guys hear me?
Yeah.
Yes, we can hear you.
All right.
Yeah, we can hear you.
Welcome. All right. So today we are going to get started with our first lab, which is going to be the SetUID. And so I will go over some of the topics. I think some people. Okay. So before we get started, let me just take a picture of everyone that's in the class so I can take the roll. Okay. All right. So I think I have it now. All right. So today we're going to, you guys know how to use everything. As you know, we're using the seed labs. This is set of labs under software assurance. So let me just go there. Seed labs. All right, let me share the material. Okay, so as you know, these are the website. You guys can see the website, correct?
Yep.
All right, so remember, just, quick reminders, we're using this VM, so just, download it if you don't have it, or maybe download a new one. This semester, we'll be doing a lot of the seed labs. I would say a lot of the seed labs are software focused, whether it's C, C++, or web security. And so definitely it ties in really well. So let's go through them. Using 1604, software security labs, you can see them here. And then you have your web security labs. So these are the ones we're gonna do later in the semester. SQL injection, cross-site scripting, and cross-site request forgery. And then there's a lot of these, right? A lot of these, format string vulnerability, race condition lab, SetUID lab, which is the one we're gonna focus on. And I've modified this lab a little bit. So there's really, today, this lab is simpler than the whole SetUID lab there, buffer overflow. Okay, some more people came in. All right, so the SetUID lab really is about, getting started with this, right? So we can take a look at this. You can see this ties in really well to chapter 1 of your book. So definitely, if you want to follow along, read chapter 1. And then there's also, the lab document that we're going to be covering. So I'm just going to click on the description here. Close this. All right, so the SetUID lab. More people. All right. All right, and so we'll talk about it. Go over some of the aspects of this lab. We're not going to cover all of it. Now, be aware that this is the lab. These labs, the next 4 weeks of labs, are going to be focused on C and C++ language. So definitely remind yourself of that. And this will kind of just motivate, what it is that we're doing, exploring today, kind of the pipeline, right? So a little bit about what SetUID is, okay? And then we're going to really just try to achieve one objective of the lab. So you certainly can read through this document. I suggest you read through it. Okay, but I'll be using the one I posted on Blackboard. It's pretty much the same thing. It only has the questions that I want to use. So let's see, 450. All right, so now let me go over here. Nope. All right, so you should be seeing the course website. All right, so in the course website, we're going to go to content. And we're going to go to the SetUID link, click on that. And as you can see, we covered the slides on Tuesday already. So really today, we just have these two documents, okay? So let me open this SetUID one. So this is an abridged version of the other one. And yeah, so we're gonna look at that one. So I'm just gonna download it. All right, and also download this document, which is the Word document. So as I said, I changed it a little bit, because I do change it sometimes from semester to semester. And that should give us kind of what we, so for this one lab, you have to follow really the Word document that I provided. Okay, so that's really the, all right, so I opened the Word document. Can you guys see the Word document right now?
Yep.
Okay, that's what, okay, great. And then I'm also going
we don't, it's not green or.
We see your browser.
you see the browser, okay. Yeah, so I need to switch to
There we go.
Now you see the PDF.
Yep.
Okay, so we're gonna do this lab, SetUID, but I have the Word document here. And also what you can do is on your own computer, you can always go to Brightspace and download the documents, right? So you can also do that and look at them. Let me switch to that Word. I think it's this one. Here we go. All right, so now you should be seeing the Word document, right? So as you can see, basically today is just really, or this week's lab is just really a simple warm-up, you know, kind of a warm-up of what's to come. All right, so let's get into it. You know, you guys are seniors. You know, we've done a lot of classes together, so you kind of know how to just do this stuff. All right. So basically, this lab has two problems. Number one and number two. And as I usually do, I'll kind of start with the lab, ask the questions, then go back into the discussion, the theory, and then you know we can work on the lab. But let's just kind of frame the problem that we want to address. Okay. So in problem number one, you're going to complete the problems from the SetUID lab handout as indicated by the instructor, by me. So for these problems, now sometimes you will need to be root and sometimes you will need to be a regular user C. Now that's a very important distinction in these labs because that's the whole point of the lab, right? The whole point of, remember we talked about this on Tuesday, in the next 4 weeks, we're looking at basically exploits in memory, right? How can we exploit a vulnerability? So that basically means that you're going to try to inject code in some way in memory, and you're gonna try to create unexpected behavior. And then your ultimate goal will usually be to read some information from memory, to steal some information from memory, maybe to change information from memory, and sometimes even to get a root terminal. So why is it relevant that when you do the attacks that you should be a regular user instead of root? What is the relevancy of that? Why is it important? Yeah, go ahead.
What was the question again? I'm sorry.
The question is, you know, the lab said, and this is I stress, this is very important because when I when I look at your lab responses, I will be looking to see what account you use for what. Did you do this as root or did you do this as C? So if we're trying to take over terminals and get a shell, you know, through an exploit, why does it matter that we should do this as either root or a regular user? What's the difference there?
I would think that as root, you have more access or more privileges than if as a regular.
That's right. So if you're already root, why hack into the system, right? You're already root. You can already do anything. Does that make sense?
Correct.
So that's why in a lot of these lab problems, you really have to stress to me, you know, and every time I look at one of the problems, I will look for the account that you use. So you have to kind of really highlight and say, okay, here I'm just a regular user. I don't have any privilege. Now I'm going to do this. And you're going to have to then say, okay, I was able to get the root privilege or I wasn't. You see that? That's really the key idea in this lab. This lab is a lab that can be a little bit confusing because it seems like you're not doing much, but what you're doing is you're trying to study this relationship between a regular user and a root account because your ultimate goal is to get the root privilege, okay? So the basic idea is that you would be logged in as a regular user, but after executing certain commands, you could end up with root privilege. That's pretty much what I just said, okay? And so that will be the ultimate goal of this lab. And as I said, the lab is pretty short and pretty easy, but at the same time, that can be confusing. I've had students that do the entire lab as root. They think they did it correctly, and they wrote the right commands, but it wasn't right because they were not supposed to be root all the time. Okay? So given that information, you're going to perform these 4 tasks: 1.2, 1.1, 1.2, 1.3, and 1.4. And there's really only one problem, which is the last one. The last problem is kind of you'll have to kind of research about it. But that's really the other ones. I would say these 3 steps are really just warm up. You know, you're just kind of trying this, trying that to get acquainted or get information that you will need for problem 4. Okay, I'll describe all of this in detail, of course. That's what I'm doing now. But I just wanted to stress that they're really all leading up to 1.4. So when I grade, I'm not paying so much attention to these. I mean, I'll look that you did them, but really what I'm looking for is what is your screenshot here? And did you do that right? Okay, so just pay attention to that. So we'll come back to it. And then number 2, as I said, I've already motivated what the class is about on Tuesday. This is software assurance. So it's really about writing code and figuring out what's wrong with the code. So a second thing you're going to do in this lab is you're going to take the code that I provided down here, and you're going to run and compile the following code and explain why the following code is not secure. So you will need to provide some comments or something. So if you look, it's a C program. You guys took C in one of your courses. So all you have to do is type it, run it, compile it, run it, make sure it runs. Remember, you're going to use the GCC compiler, which is already available in Linux. And then look at this code. On the exam, usually what I do is I provide pieces of code like this. Okay, so on the exams, you'll get pieces of code like this, and the question will be pretty much this question. You know, explain what's wrong with the following code. Obviously, we're going to look at this in the lectures. I will point out a lot of issues here. Once we get to future lectures, I will address what the problem is. But for now, I just want you to tell me what you think the problem might be. So study it. Okay, don't tell me right now. But this will be part of your assignment. So run it, and then figure out maybe how to break it, And then it doesn't have to be that you hack. Remember, software assurance is not about just security. It can also be quality. So just try to break it, figure out if you can break it, find the problem with it, and explain it. So that should be pretty straightforward there on problem 2. Then let's go back to problem 1. Are there any questions about problem 2, I should say? So as I said, we will be writing several C programs or using several C programs, compiling them. So you must remember that you have to use the GCC compiler on the terminal to compile your code. Okay. So no questions on problem 2?
Yeah, what does the asterisk mean in C again? I forgot.
Pointer.
Pointer, right, okay.
So just try it out. And as I said, we will get to it. Don't get scared, like, you know, I'm not going to be asking you to write programs from scratch. Okay, so that's one thing. It's more about, so it's not a software development class. It's more of now pointing out what are some common errors, okay, that could result in either security issues or quality issues. All right. Okay, so anyway, so that kind of motivates what you have to do for 2. Now let's focus back again on 1. So as I said, I stress what's important here is that sometimes you will need to be root and sometimes a regular user seed. Okay, and the basic idea is that you would be logged in as a regular user, but after executing certain commands, you could end up with the root privilege. So the way this is going to work out is that you're going to go usually to the terminal, you're going to create some scenario, your seed, you're going to try some things, and then after a while, you get a new terminal, and you're going to type on that terminal, who am I? Or you're going to type the ID. So when you type the ID, if you're root, if you're a regular user, what ID should you get? If you're just a seed account, what ID do you usually get if you type the keyword ID? Anyone? What's the standard seed account ID? It's 1000. What about the root account ID? What's the what number is it? Guys, anyone?
0.
0, very good, excellent. Yes, it is 0, exactly. And so that's important, right? You're gonna have to use that ID because later on we're gonna learn that in accounts in Linux, sometimes you have what is called the real ID and sometimes you have what is called the effective ID. And so that's also something that we will need to discuss later on. But you need to identify those things. If you type who am I in a terminal, it'll just tell you your name, right? So it'll say seed or it'll say root. But you will have to use that mechanism quite a bit for the next 4 or 5 weeks to figure out the account. That's, you know, a lot of what we're doing in a lot of the problems, regardless of their complexity, will be that, you know, okay, I just got a shell. Am I seed? Am I root? Did I achieve my objective or not? All right. So this example should be pretty straightforward. Okay, so let's go through problems 1, 2, 1, 1, 1, 2, 1, 3, and 1, 4. So solve the following problems and show evidence of your results and conclusions. First step is just, you know, like an exercise. You're going to copy several programs as indicated in the task 1 of the PDF or of the lab to the temp folder. And then you're gonna run them from the temp folder, okay? And then all you have to do is you have to explain, what do you notice? You know, why do certain commands need to use SetUID security? Why does, for instance, the Passwd function need SetUID privileges? That, Okay, so the very first question is really just about understanding SetUID. And as I said, I will provide some additional description of that shortly. Okay? So a couple of things about that. When you are on anywhere in the terminal and you type, let's say, Passwd, all you have to do is type Passwd, right? What is that command for? What is that command for? Passwd.
To change password, right?
Change the password. Very good. So whenever you do that, Passwd is really a little program that's a script, right? It's a script. It gets interpreted by bash, right? Bash on the terminal. The interpreter that you have, your shell basically, it's called your shell that's associated with your account. And then usually what you have is you have like environment variables, right? So you have a general place where you have your variables, and that automatically, when you type Passwd, it connects it to the actual program that you have in for the system. However, what you're gonna do here in this example is that you're actually gonna go to where Passwd is, and you're gonna make a copy of it and put it in the temp folder, okay? So you're gonna take that Passwd program and copy it to the temp folder. And what I want you to see is, you're gonna have, again, the option of copying it as root or copying it as seed, okay? When you do this, you need to check the privileges and permissions of the Passwd program in its folder versus the copy that you just created in the temp folder, okay? So that's an important thing. Now, I want you to copy all of these programs as both regular user and root, okay? And in all exercises, you're going to explore their privileges, okay? And in particular, you're going to explore the, as you know, the Linux security parameters, okay, of each file. You're going to do like ls-l, and then you're going to see everything in there, the permissions. When you copy a program into a temp folder, you also will have a second copy of it, right? So now you will have a second copy of it. This, right? So you'll have a second copy of it in temp. So you have temp, right? And in it now, you're going to have a new copy of Passwd. However, you have to think about this. If you just type, if you go to the shell, the terminal, and you type Passwd, even if you're in the temp folder, what's going to happen is that the operating system is going to check your environment variables and run that copy of the program. Does that make sense, guys? So if you want to run the local copy, the one that's in temp, you're going to have to do something like /Passwd in that folder. That will make sure that you are running the actual program, okay, that you just copied and not the program that is the general program. Is that clear, guys? That difference, because what might happen, you might get confused in this lab if you're always typing this and you're running the actual original copy instead of the one that you put in the temp folder. It's not going to work. So I do want to stress that there's a difference. Okay? Questions about that?
We're good.
Okay, great. So you guys get it. I think we've done it in 372. All right, so that's the idea. So if you imagine problem 1.1 is really just about that. Be root, be seed, grab a few programs. Really, you only have to look at task 1 in the PDF to kind of, for commands and also for a list of a few programs. It doesn't, just 2 or 3, copy them, analyze it really well, okay, because it's really for you. It's not really for anything other than for you to get a good understanding. Okay, so if I copy them as seed, right, into temp, okay, and I look at the permissions, this is different, this is the same. Who owns it now? So key things that you need to consider when you're doing things is things like that is who's the owner? What are the permissions? Right? And also SetUID. Is SetUID set or not? Right? And those are really the three things that you're looking at. And so you're going to explore that when you're seed. And then now, okay, if I use root and I copy, who's the owner? What are the permissions? And also what is SetUID? Okay? These are that's really all that you're doing there. And it, as I said, it's just a warm-up thing to kind of always be mindful of the fact that you need to look at these three things. Because these three things are the key things that determine if you're going to be successful or not in what you're trying to achieve, which is always to really at the end of the day, what you're trying to do is your seed, but you're trying to escalate your privileges to be root. Ultimately, for 4 or 5 weeks, that's all we're going to try to do. Okay, we're going to try to accomplish that goal. Okay. All right. Very good. All right, so that's the first one. Then on the second one, so now let's look at this one. So now this takes us to another little thing called bash or dash or CSH. Anyone know what these are? What are those? They're Unix shells, right? So they are basically the command processors that you have on the terminal, okay? These are the things that whenever you get a shell and you type a command, these programs interpret that code. Because every command that you type is really a little script. And so that little script needs to be interpreted, okay? And so this is constantly changing. You know, it goes from bash to dash to CSH, but ultimately all of them are just programs. And even these programs that are command interpreters may actually have vulnerabilities. And so now it starts to get interesting, right? Because now it's where you're going to try to say, I'm going to try this with one of these that might have a vulnerability. Can I exploit that vulnerability? And so that's the idea, okay? So what you're gonna do is you're gonna play with bash and CSH, right? These are programs also located on your computer. And you're going to copy bash and CSH into the temp folder again. Now, the key question is, once again, just like I said before, right? You're gonna repeat the exercise. You're gonna be seed or root. You're going to copy them. And then every time you're going to check 3 things. Who's the owner? What are the permissions? And SetUID. Is it set or not? You should know, you're going to need to know 2 things. How do I set something to be SetUID? I will give you that command. And then also you're going to have to know how to check if something is SetUID. Anyone know how you check if something is SetUID in the terminal? How would you know if I asked you, tell me please if Passwd is SetUID or not? What would you check for? Okay, so that's fine. So there's going to be a little flag in the flag of permissions. It's going to be a little S. And that S helps you to know if something is SetUID or not. Okay, so don't worry about it. If you don't remember, I will go over that in the discussion a little bit later, but I'm motivating the lab right now. So anyway, so you're going to copy bash and CSH as seed, as root, explore these. Then you're going to make both of those SetUID, and you're going to run them. These programs are shells. So whenever you run a shell, all that happens is, let's say you're like, you're in the terminal, right? That's the terminal. And then you say, you know, ./CSH. And you run that command, and then what's going to happen is, boom, you get that. And that just means you just got a shell, okay? You just got a shell, but the shell of CSH, the program that you just ran. So that's really what that means. So you're going to run these 3 shells and just explore what happens. You know, on here, you can type ID or who am I? And once again, you're going to explore if you have, what permissions do you have? Obviously, your goal would be that you were seed when you ran this. And if you notice, I was, right? Because I have the $sign here. What's the symbol for the root in the terminal? Somebody wrote something. That's right, $sign. So the $sign, so these are parameters that you need to, you know, that's why I said this lab is easy, but it's cryptic, right? Because, you know, you're looking at things, you want to figure things out, and really you just have this, that, or that. And when I'm grading your lab, I am looking at these 3 things. Okay, they did this command, but, they used that. Okay, good. They did this other command and they were root. Okay, that's wrong. That's, you know, that's how I will know. So that's why it's really important that you pay attention to this lab carefully before you just do it. You know, don't just like try to type commands. Instead, I want you to really think about it, because it lays the foundation. You know, the thing about these labs, we only have 4 labs for this sequence, but they build on each other. Today, this lab is just about this, like account, permissions, SetUID, all of that, bash. The next one is a little bit more about memory. And then the next one is really about buffer overflows. And so really, someone else came in. Yeah, I think I let him in. All right, and so that's really, really important, okay, that you stress this, that you stress this, this concept very clearly. So this lab, take your time. It's short, but take your time to understand what it is that you're doing, because otherwise you're going to be really confused later on if everything that you do ultimately just comes down to, did I get this? Did I get that? Or did I get this? Okay. All right. So once you, so these are the programs, bash dash CSH, that we're going to play with. Copy bash and CSH as described in the lab to the temp folder. Make SetUID, run them. And then the question is, do you get root privileges after running them? Explain what is happening. So I'm really there in that section of the lab, just looking for your own discussion. Okay. All right. 1.3. So 1.3 is going to be just getting, again, reacquainted with C++. So create a C program that includes a system call. Okay, you're going to find an example of a program in C that includes a system call in the PDF that I've attached. Okay, so all you have to do is that, create a C program that includes a system call. Now, why a system call? A system call is important because this is the thing that is going, this is the threat vector in our software. This is the thing that we're going to try to exploit, okay? Because a system call basically means that we are sending commands to the CPU. You know, we're getting access to that. by running instructions as a system call. And you will start to see that that's really our target. Okay, you're gonna zero in on that. So for now, all I want you to do is find a C program or take that program that I provided in the PDF that has a system call and compile it and run it. Read the code, become familiar with the code. Make sure that you know how to compile and program, compile C programs in Linux. All right? Are there any questions on question 1.3?
Nope.
Okay, great. So it's important that you understand that it's not just about, you know, typing and compiling a program, right? There's the key element of the system call, which creates the vulnerability that you want to exploit. Okay. All right. And then finally, once you've done all those things and you've thought a lot about what it is that you were doing with 1.1, 1.2, and 1.3, really, as I said, what I'm looking for is that you solve a little program or a problem like this one. Okay. So you're going to, in 1.4, you're going to create a program. So that just means, you know, a C program with a system call probably, right? So you're going to create a program. Now keep in mind here, as root, you need to be root. And you need to figure out why you need to be root when you create that program. Then you're going to have to use the SetUID mechanism. So that means you have to set it as SetUID. It has to be a SetUID program. Okay. You're also going to create a secret file, you know, just any text file, put a secret message in there, secret key, and only root can view that file. So you have to also create that, right? You're going to have to create the root owned file, a separate text file with a secret in it, and it's going to be owned by root, and you're going to have to play with the permissions so that no one, not another user, no group, just root can read it, okay? So that's the key thing. Then you're going to test viewing the file with the seed account. And you're going to make sure that if you use like nano or cat, you won't be able to view it, right? Because if a file is owned by root, then seed cannot read it. So that's the first thing, okay? You don't have access to it. You don't have permission. You're going to provide, you need to provide a screenshot of the permissions of the file as well. Now, the goal of this problem is, that if you are seed, you will try to read the file directly, okay? But you will also try to read it using the program, in particular, this program that you created here. So obviously this program needs to have some functionality to read the file. And then the objective is that you should not be able to read it as seed with cat or nano, but the SetUID program, this one, may allow you to read it. Do you guys understand? So one trick to this is that you can have a system call in the program, and the system call is just something like cat the file. You see that? Cat the file. And so you need to figure out, by playing with copy, ownership, and the SetUID mechanism, right? By playing with those things, you need to create a scenario or an experiment where you're able to read a root-owned file, even though you are only seed. Additionally, you're going to be, whenever you run a script, etc., you call your shell, right? So you're going to call your shell. And your shell, in Linux, we have several shells. We have, as I said, bash. And really what bash is only a pointer. It's only a symbolic link, sorry, to two programs, dash or CSH sometimes. So you'll have to find out on your system where bash is. When you do ls-l, you will see that it's actually a symbolic link. And then you need to find, you know, the interpreters that are available, dash, CSH, and so on, and then change the symbolic links. Okay, so you're going to explore in the seed labs. One of these may have a vulnerability. Okay, and so that we'll talk also about that vulnerability. But if you find that vulnerability, you might be able to exploit what you're trying to do. Do you see what I'm saying, guys?
Yep.
Okay. Are there any questions so far?
Not from me, no.
Okay. All right. So anyway, that's the general idea. And then what I will do next is I'm just going to provide, now that I've motivated all these problems, you in your minds have, you know the tasks that you need to complete. And so now I'm just going to talk about several of these things like, SetUID, etc. And then you can use that additional information to start crafting your lab solution. Okay. And that's really the lab. So this lab will be due next Thursday by 10 p.m. Okay, so you're going to submit it on via Brightspace. I will create the Dropbox. And for this one, I will just say complete the questions in this document. Okay, so that's all you have to complete. And you can use all the other PDFs, the one that I showed you on the website or the PDF that I attached as more information for examples. But really, I just want you to focus on this little set of steps. All right. So let's now that we've talked about that, let me go back to the PDF. Wait. Go over here. I think, no, it's not. Huh. I'm looking for this. Wait, let me find the PDF. I thought I had it here. Oh, here it is. Okay, so I'm gonna new share. Are you guys seeing the PDF document?
Yes.
Yes.
Okay, great. So just a little bit of information here, just to point out a few of the things. So first of all, SetUID, right? So I know this is something that I remember we discussed in 372. We went over that when, the Linux commands for that, but I will go over it again, make sure everyone is clear on it. Please stop me if something is unclear. All right, so SetUID is an important security mechanism in Unix operating systems. When a SetUID program is run, it assumes the owner's privileges, and that's really the trick, okay? For example, if the program's owner is root, then when anyone runs this program, the program gains the root's privileges during its execution, okay? So again, think about that. For example, if the program owner is root, when anyone runs this program, the program gains the root privileges during its execution. Now it could sound dangerous at first, right? Like, oh, so if I just run this, am I root now? No, you're not root. You just gain root permissions for that specific task governed by that program. Do you guys see that? So you're limited to whatever it is that that program has set Now, if you could somehow, imagine that when you run a program that is SetUID, right? So it's got some variables in it that say, oh, your effective ID is now root. But it's only for this program. And the second you stop using the program, your effective ID goes back to being your real ID, you know, whoever you are. However, imagine that this in memory is some kind of a context. Now imagine if you could somehow be in that environment, but then trigger a new, or spawn, as they say, a new context. So if you could spawn a new context, like create, you know, break out of that into another context, then what is your effective ID now? Is it the one that you had in the previous program, or should it go back to the real one? What do you guys think? It should be your real one, right? You should not, in fact, be able to, you know, have this privileges in this control domain, but somehow figure out how to break out from it and retain the permissions, okay? If a program, if operating systems or functions allowed you to do that, then they have a serious vulnerability, okay? And so that's something that you need to understand, that we're gonna be talking about a lot this semester, or the next 4 or 5 weeks. That's one of the main concepts, okay? So SetUID is necessary, but at the same time, you know, it illustrates really well what could happen, you know, what bad things could happen if you were able to break out from the program into another context, okay? So as I said, so if the program's owner is root, then when anyone runs this program, the program gains the root privileges during its execution. SetUID allows us to do many interesting things, but unfortunately, it is also the culprit of many bad things. Therefore, the objective of this lab is twofold. Number one, appreciate its good side, understand why SetUID is needed, and that's why you do some of the things I mentioned, and how it is implemented. And two, be aware of its bad side, understand its potential security problems, okay? So don't worry if some of this is not clear to you right now. Certainly all of this will be clear, because we're really just exploring in the next few weeks one like specific set of ideas. They're all interrelated. Okay. So that's kind of the description. This is an exploration lab. And your main task is to play with the SetUID mechanism in Linux and write a lab report to describe your discoveries. So, you know, this is the first problem. You're going to copy these. You know, you don't have to do all of them. You know, even 2 is fine, but definitely copy Passwd. Okay. Then you're going to play with bin, right? So you have to read through this document. It'll tell you where these are located. Copy these as I indicated. Again, read the permissions, copy them with your different accounts. Okay. This is something that you're going to need. These commands here are the commands to change the symbolic link. All right. So whenever you go into bin and you do ls-l and you find bash or something like that dash, you'll find a symbolic link. So if you, for sh, which is the shell. So if you want to remove that symbolic link from sh, you delete it. And then if you want to create a new symbolic link between sh and a new program like csh, then you run ln-s csh sh, okay? So that's the idea. This, you're gonna perform a lot for the next 4 or 5 weeks as we're working through these C-related labs. You're going to be removing symbolic links and creating new symbolic links, okay? Are there any questions about that so far?
Nope.
Questions, all right, wow. So it's
Good so far.
everything's clear. Okay, that's good. I mean, that's good. Usually I think this lab, students find it a little bit difficult to understand what it is that they have to do, but okay.
What's going on here is you're creating a symbolic link for shell to
Yes.
to a
Yes.
different program.
That's right. So whenever you type sh, what sh is, when you type it, is it's a symbolic link to bash. So really what you're running is bash or dash or csh. You see that?
So both of those two different programs can have different privileges, right?
So they're both the same. So bash, dash, and csh, they would end up being the same type of program. And sh can be just a symbolic link to use any of them.
And that both of them requires a root privilege, right?
Well, that's what you have to explore. First,
Okay.
look at the privileges of sh, right? What are the privileges that it has? Then you're going to copy as seed and as root, and you look at and also the mechanism of SetUID.
Okay.
You understand?
Yeah. Thanks.
But so what he's saying is CSH, this one, or bash or dash or whatever it's called now, they're really just little programs that allow you to interpret commands. So that they themselves are it's like they're software that interprets other software. But sometimes they change. But there should be like a single word that you can use generally, and that's sh, and that's why you have a symbolic link. So it's similar to, let's say that in some programs, Java, the version is always changing. So today is Java 12 and then Java 13.5. But you really just have one variable called Java, which is a symbolic link to any of those versions, the latest, let's say. Okay? All right, so I think hopefully that's clear. So again, that's important for that. And here, this is the code that I said for a symbolic, to execute a command, right? So this is not a symbolic link, sorry, for a system call. Sorry, that's what I meant. So this is the program for a system call. As you can see, you got system there, and if you notice, right there, you got the ls command that you would usually type in the terminal, okay? So you're going to also write that program just to kind of see how it works, okay? So a lot of these pieces then you have to bring together to try to, as I said, ultimately at some point you want to get from seed to the root privilege with a terminal. All right? So that's the program, and then after that, read through everything, make sure it's clear. But we're not going to do all of this here. All right, and that's it. All right, so that's pretty much a discussion in that PDF. All right, so now let me open a, oops. Okay. All right, so now let's open, I'm just going to open a new, like a set of slides, and I'm going to, no, wait. So I'm just going to go over now a few more concepts. So, you know, like the board. 450, lab 1. So let me open 450. Okay, so I need to share the slides, correct? That's what I need. All right, so I'm going to share now. Oh yeah, I forgot that I have the. You don't need me to save these slides, correct? It's fine if I just do it on the whiteboard of Zoom and then it's in the video. guys?
Yeah, it should be fine, I guess.
It should be fine?
Yeah.
Okay, so, because if usually I remember I used to just write on the slide and then I would upload that slide. But I guess to print, you guys would print that. But here, if I write on the whiteboard of Zoom itself, I cannot save that to a file. So it'll just be in the video itself. That's okay. Does anyone object to me just writing it on the whiteboard of Zoom and not on slides?
That's fine.
No.
It's fine. All right, so everyone's fine. All right, so there we go. So let's go then just to the whiteboard. We'll just use that. Yeah, the lab is due. This lab will be due a week from today, at Thursday at 10 p.m. Okay. All right. So you guys are seeing my the whiteboard at this time?
Yes, we are. I mean, I am.
Okay, great. So let's go ahead then. All right, so this is the information for lab 1. Okay. Some of the things that we're going to discuss are bash in general, what it is, provide a definition for that. Remind you of the SetUID, stands for Set User ID. Give you some of the commands for that, what it is. And then from there, you'll have pretty much everything that you need to solve this lab. Remember, a lot of these labs are about, solving something. So really, I want you guys to think a little bit about them. All right. Let's get started with bash in general. I know I've mentioned that term. Okay. So what is bash, for instance? Let's take that as an example. So bash is a Unix shell. All right, so have you guys heard the term shellcode? Have you ever heard that term, shellcode? Have you come across it? Have you seen it somewhere? Shellcode? No?
Yes.
Yes, okay. So shellcode is basically the bash program. If you want to imagine bash, right? Bash is a program. Let's just imagine it's written in some language. Let's say C or C++. Let's say it's written in C, then it goes through the compiler, and then from the compiler, it what does it do? It gets compiled into like assembly code, and everything, and then it ends up being machine code, right? Or you can look at it as assembly code, right? So let's say, actually, let me. Be more specific, so then assembly, right? And then then it becomes, it looks like, hex, hexadecimal. So if you look at it, and it keeps going all the way down, like binary, right? So it keeps going like that, right? Make sense? So on a computer, you have memory. On a computer, you have memory. So this is memory. And then you have the CPU. The CPU has little registers. These are called registers. There's like little variables with addresses or data in them. And usually there's one register in there. You might imagine it to be like a pointer. What basically happens is it knows, okay, here's the next command that I need to execute. So it's like I have the address to that place. Do you see that? And it knows, okay, that's what I need to do, right? However, what's this going to look like? do you think? This data here, what does it look like? Let me give you like A, B, C. Do you think it'll look like C, C++? Do you think it might look like assembly? Do you think it might look like, let's call it binary or machine code? Sorry, let's be more. Machine code. Oops, that is not what I was trying to do. Okay, machine code. So which one of these do you, so as I said, the CPU has an address and it knows I need to execute some sequence of commands that is written there, right? You know, usually specific to the CPU that you're using, Intel or AMD. So the code, it's obviously it's some program, right? It's a program. So what do you think the program or the instructions that are located in this place in memory, what do you think they look like? Do you think in the sequence of coding, this being bash, the application at the very top, do you think it looks like C++? Does it look like assembly, more like hex, binary, what? What do you think? Of these A, B, or C, which one do you think?
Maybe more binary?
Yeah, more binary, right? Somebody said D, there's no D. So machine code, let's say, right? And so it's going to be, you know, imagine a series of zeros and ones, or, you know, some set of instructions that the processor understands, right? Now think of this next question. What if now I want to hijack a program, right? Let's say that I could somehow insert in here, let's not worry about the how now, but let's just say that I could insert here an address to another location in memory here. And in that location in memory, as it turns out, I'm going to put another set of instructions. You see that? So for me to be able to succeed, right, I would have to change this address, right, to point now, instead of to the right place, to that place. And in this location, I would need to put in new instructions. You see that? So a lot of what we're going to try to do in the next 4 or 5 weeks is that, okay? I want to corrupt the process, right? I want to make the CPU jump to my designated address, and I want it to run my designated code that I have in here. I have my code in here. Now, so assuming that we could do that, those two things, put something here and put something there, what do you think you'd like to put in this section? What would be a good idea? And remember, whatever is in there is going to get executed, right? So you're going to execute a sequence of commands, right? So or let me put it, imagine it's like a script. So whatever that script is, you're going to run it. Or another way of putting it is a C++ program with a system call, right? So if I was able to put that in there, right? Then what do you think would happen? The CPU would execute that sequence of commands. You see that? And so what would be a good thing to put in here, you think? What's the one thing that you want if you're a hacker and you're seed, but you want to take over that computer? What do you?
Privilege.
How do you get that privileges? What do you need?
SetUID.
Well, SetUID is a mechanism, but what's the thing that, you know, you log into the computer, what do you need? To type commands.
Password.
Hmm?
Password.
No, well, yeah, that's for permissions, but I just mean the mechanism in the computer that will allow you to type commands. What is that called?
Shell.
Perfect. Shell. That's what you want. Oops, what happened? Okay, so shell, that's what you want. That is the as a hacker, as an attacker, whatever, that's the thing that you want. And then once you have that shell, what happens if you get a shell, but it's a seed shell? If it's a seed shell, that's
Access, you don't have access to.
you don't have access. So what's the point? I mean, you got a shell, but you know that doesn't help you. So it's a combination of a shell with the root privilege. Does that make sense, guys?
Yep.
Yeah. So that's ultimately the whole little game that we're going to be playing for a few weeks, is getting that shell with the root privilege, and all of these ideas tie into it. So going back to this idea of bash again, I'll ask you the question. So what do you put in here then? Assuming, don't worry about the address part yet, but assuming that the CPU has a register that tells it where to go, assuming you can figure out how to change that address and redirect to this place in memory that you've allocated, what do you want to put in here as instructions? What would you want to put in there as code? Let's rewrite it as code. What code do you want to put there? So that the second the CPU starts, boom, it gives you that. It runs that program. You want to put the paint? You want to put what's another? The calculator? Is that what you want?
Sorry, would you put like that SetUID there so that you can?
Not the SetUID. Remember, the SetUID is just a thing that we will use, but the program that we want in there is the shell. Remember?
Okay.
Yeah, that's what we want. So that's where I was going with this. So what the code that you want in there is the code for shell, because shell is a program. That's the point I'm trying to make. Bash here, which is, sh, right, is pointing to bash or dash or CSH, whatever you want to call it, is nothing more than a program. You see that? Code, C code, has a system call in it. That's why you're doing all these things in the lab. And it needs to go through all the steps of compiling, right? Assembly, all of it, all the way down. So again, the thing that you want to have in there is bash, and that's usually why that is called shell code. You see that now, guys? This is make sense? Make sense?
Yes, it's starting to make sense now.
All right. Now, another question. Now you need to insert that code in there, right? So do you just grab the program in C, C++, and do you put it there? Or what do you think you would have to grab?
Would you have to put it like in a temp file or?
Say that again?
Would you have to put it like in a temp file too?
You have to put it in memory. You literally have to, there's no temp files here. You will literally have to find ways of take shell code and load it in memory somehow. That's the trick that we're trying to understand, right? And so that's why I said this takes 4 or 5 weeks, but we will get to it. But it's a general picture. Now my question here is, we want the bash program, one of them, to be in there, right? Let's call it shell code. Now we cannot just take the C++ program and put it in there. Why? Because remember, this is at such a low level that it's the CPU that is going to process those instructions. The CPU does not understand C, C++. What do you think the CPU understands?
Machine language.
Yeah, but the machine language, exactly. It's going to understand the compiled version of it, right? So that's the other piece of it, is that we need the shell code, but it needs to be the shell code once it's been converted to the hardware level. Exactly. Very good. Very good. All right. And so this is the whole process, And that's why we're starting at the definition of bash, because ultimately we are going to want shellcode in memory, and we need to figure out how to get there. The address, that's another problem that you will have to solve. And we are going to explore all of this as we try to get in there. Now, this program is very short. So really the shellcode that you create is also very short, okay? All right. Are there any questions about this idea so far?
Oh my goodness.
No? Making sense? All right. So now that we have yet more motivation as to the problems that we're trying to address. So now let's think about, go back to bash. Okay. Or, you know, what are these? These are command processors. Okay. So this is a command processor. Okay. It's a command processor. Run in a text window. Okay, and it allows the user to type commands which cause actions. And so that allows the user to type commands which cause actions. Well, with that definition, that's definitely what you want if you're trying to take over a system, right? Hey, how can I get a command processor where I can type commands that cause actions? Oh, and by the way, I also need to have root privileges. Thank you very much. So that's really what you're going to, that's your target. That's your target. Bash can also read commands from a file, which is called a script. So you do this all the time. So that's the definition of bash. It's a program. Then there are, the SH is linked to, you know, dash or bash through symbolic links, CSH, and so on. I don't know how many, there might be more. All right, and these programs are, again, software. So if you know that you need to do software assurance with code, that implies that this software could have intentional or unintentional vulnerabilities. And if it has a vulnerability, you for instance, want to exploit, okay? Now, CSH, you know, it's again just C shell. I mean, people that create this aren't very creative about the names. All right, so literally Z and SH. All right, so so it's a shell that can be used also as an interactive login shell and has a command interpreter. So it's basically just versions of different versions. Okay. Now, so I've talked about that. I've laid down the idea for bash. So hopefully that made sense. And now I'm just going to talk about the SetUID program. I'm going to switch to a new command. And this, I'm going to provide some commands. So first of all,
Sorry, Professor. All this, that you write on the whiteboard, it's going to be uploaded to Brightspace, right?
the video?
What you're writing on the whiteboard right now, are you going to upload it to Brightspace?
The video, you mean?
Yes.
Yes, that's the question I asked before, right? That if you
Never mind. Never mind.
remember the question, if you guys wanted me to write on a PowerPoint or write on whites, if I just write on this board, it's only in the video.
Okay, perfect. Okay, that's fine. As long as we have it somewhere, it's okay.
It's going to be in the website, in the calendar where I put the videos.
Okay, perfect. Thank you.
Okay, that's what I'll do. But my point is there won't be like slides that you can print. Okay, you can only have to
Oh,
watch
that's
the
fine.
video to get these notes. Okay,
Okay.
that's fine. All right. That's why I asked, because I wasn't sure. All right. So now let's move on to the next idea, which is SetUID. This is really just a review of what we covered in 372. As you will, you will see pretty much the same thing. So SetUID stands for Set User ID, right? So you're basically setting an ID. What happens is in the privileges, you know, let's say you have a file in the file permissions, and remember these, right? The permissions. Right, so you guys remember this is owner, this is group, and this is other, right? You remember that? So whenever you set SetUID, what's gonna happen is this X here, that stands for executable, will be changed. Will be changed to an S. That's it. That's all you will see in a file. So this is file one, whatever, .exe, let's imagine. And whenever you make it SetUID, you now change that to an S, and then over here, remember, you have owner. So if the owner is root, actually it looks like that. If the owner is root, let me write owner. Okay, so if the owner is root, then what's going to happen with the SetUID? It's the definition, right? The program runs with the privileges of the owner. So a program that's running with the privileges of root means it's, you know, it's got all that power. Okay, and these are called privileged programs. Okay, and when we have privileged programs, they become targets, basically. They are targets. Okay, so these become targets for, you know, people that are trying to exploit them. All right. So what is a privileged program? Okay, so that's the central question there. What is a privileged program? And so that's where you know, because this ties into the idea of access control. Right, so access control. Okay, so, you know, privileged programs, you know, allow you to bypass access control, because access control can be a little bit restrictive in the way that it was done. And so SetUID is almost like an exception, right? You know, if you think in a perfect world, there should be no SetUID. Access control, which is, you know, these rules over here should take care of everything. But then what happens when you need to run a program on a file that is owned by root, for instance? Then you have a problem. And so that's really why you end up with the need for SetUID. So as we talked about, what the thing that's important here is the real ID versus the effective ID. So whenever you're running a program, the program is associated with, in the operating system itself, with regards to access control, it is associated with these two types of IDs. Okay, it's associated with those two types of IDs. So as you know, and as I said already, seed, don't forget, is 1,000, and then root is 0. Somebody wrote something? Okay. So that's the idea there. So that what happens is the system, the operating system checks the user ID. Right, so it'll check the user ID and it'll check the permissions on the access control. Okay, so it'll check that. Check for that. All right, so it'll check who the owner is, what are the permissions. If that's not correct, it's not gonna let you look at it. That's why in this lab, remember, you're creating a file that is a secret, and the owner is root, but only root can read it. And then you have seed over here, and seed will try to read it with cat or something like that, and it will be unsuccessful, okay? Because the permissions will not allow it. But let's now think of the scenario of passwords. Right, so let's think of the scenario of passwords, because this really creates a dilemma, right? Where are passwords located? So first of all, passwords are associated with 2 files, correct? What are the names of those 2 files located in etc? Anyone? All right, so there's the Passwd file, and then what's the other one called? Let's see, somebody.
Shadow, I think.
Shadow,
Something.
yes.
Yeah.
Okay, so the other one is the shadow file. Exactly. The Passwd file, somebody else wrote something else. Okay, so the Passwd file basically contains 1 line per user. So you know, if you don't remember, just go into it. You'll see it's got like the user, you know, the shell and everything, and then the shadow file has basically that user and the password. The encrypted password is there, but the shadow file is owned only by root, and only root can access it because of that. So if you're seed and you want to change your own password, what do you have to do? Well, you could call root over the phone, right, and say, hey, root, change my password. But that's not how the operating system works, right? You can, in fact, go to the terminal and change your own password. So the trick is, how do you do that? Well, there's a program called Passwd, right? It's a little program. And that program is, you know, let's say read, write, for owner, but it's SetUID, the owner is root, right? And then any other user can use that program. And whenever you use that program, the program is owned by root and it is SetUID, which basically means when you run Passwd, its effective ID becomes what? What is the effective ID equal to? What number?
1,000.
Not 1,000.
0.
0. Do you understand the idea?
If you're running the program, then you need to have a root privilege, like as you're running it. So the set ID UID shouldn't be 1,000 then?
No, because that's that's your ID. So the program has a real ID and an effective ID. So who's running so the program is owned by, let's go back to it. Passwd is owned by root, correct? You agree with that? And it's SetUID, right?
Yeah.
The definition of SetUID is that a program that runs the SetUID, any user can run it, but the program runs with the privileges of root, restricted within that program, right? So every process is associated with these 2, real ID and effective ID. if the person that starts this program is seed, then the real ID will be 1,000.
Oh, okay. I just got in. I just
You
mixed it up
confused
from 0
the
to
two words?
1,000. Yeah.
That's what you
Just
mean?
a
Okay.
number. Yeah.
Yeah.
I got it.
Yeah, so exactly. So your real ID is seed. The program knows, hey, this is seed. I know it's not root, but I'm going to, because I'm a SetUID program, I'm going to let it be an effective ID of 0.
Okay. Yeah, makes sense. Thanks.
Yeah, right. All right, there you go. And that's it. That's how it works. That's why you have this little mechanism of the effective ID and the real ID. Okay? And so we kind of have to scale up because of these issues in access control, as I said, when we have these like dilemmas, is really what this is. Any very good question. Any other questions, guys? All right, so let's keep going then. So in essence, only root should be able to read. And now maybe, now that I'm explaining this, the lab makes more sense, right? In a way, all I want you to do is the same scenario as Passwd. You create your own file, which is owned by root and only root can read it. You're trying to get access to it, okay? So only root can read, the etc shadow file, right? All right, we already talked about the program that we need, Passwd. Okay. So if a user wants to change that password, how can he do it since he does not have access to the shadow file? So this is only root. And if you directly try to change it with nano, so if you directly try to change, with nano, if seed regular user tries to read with nano, you will be denied. So you have to go through this program, which is Passwd. So since how can you do it if you do not have access to the shadow file? Okay. So the Unix solution was to invent the SetUID mechanism. Okay. All right. All right. So now what's happening is, if you might imagine, it's like, let's imagine int main. This is the, we're just imagining the Passwd program, right, inside. Okay. And then what do you have here? Oops. You have a system call. You guys see that? And then you are basically what you were trying to do before through nano, right, of accessing the shadow file, which was denied. Now it's almost, I mean, this is going to be more complicated than just this, but it's almost like this, nano shadow, right? And now you're literally running that command through the shell by doing a system call here. But because you're running it in the context of this program, and this program, by the way, is SetUID and root owned, then the effective ID of that one will be what? 0, right? Whereas the effective ID of using it through nano directly is going to be 1,000. So you get, because you're seed, so you get rejected. Is this clear, guys? Are there any questions about this part?
No questions.
All right, great. So SetUID is a program just like any other program. Okay, so that's the idea, is that you're changing that ID. Okay, so now to summarize then, almost done. So SetUID is basically a program that allows you to run a program, allows you to run a program with the privileges with the rights of the owner, right? And this, you know, which is root for this case. I mean, it could be another owner, but obviously the owner that you want is the one that has that effective, that real ID of 0, so that it can become your effective ID. And this is called, so in the permissions, this is called setting the SetUID bit, okay? And that, you know, like I described before, that's just that S parameter. Okay? And that's pretty much it. Okay, so now, so I think hopefully this makes sense now, right? So you have, you know, you're running the process, and the process has acquired the privileges of the owner. Okay, so now just, you know, just a few things. I'm just going to give you a sequence of commands of things that you might need for the lab. Okay, so part of the lab says you have to copy. So let's say this is an example of copying bin sh. Remember, that's a symbolic link to the actual program, and you're going to copy it into the temp folder. Okay. Now I've been talking about making things SetUID. So to make SetUID, you can type chmod, and then it's 4755. Those are, you know, we've talked about this before in 372, right? This is the numeric, but you know, remember you calculate the binary, right? And then you can work out the number to set the permissions. This will set the S bit on a program. So you make it, let's say for instance, in your temp, which is where you would have, you know, bash, or actually, let me just for CSH. All right. So at that point, CSH, you copied it into temp. It's a copy, not the original one. You make it SetUID by typing chmod 4755. And now you have to check who the owner is, right? For you to gain root privileges, the owner needs to be root. Okay? That's the command for that. System calls. So remember, system calls are almost equivalent. It's similar to running on the terminal. So in C, let me do it this way. In C, C++, you have int main, curly bracket, and then you have in there system, you know, ls-l, right? That's a system call. You guys see that in the code itself. But notice the importance of that. This code is similar to, on the terminal, doing bin sh mail, for instance. Assuming here mail is just the program in the system for the email, right? Or whatever, you know, whatever program you're running. So really, we're calling the shell, right? And we are calling a program. Make sense, guys? Usually I think you really just type this, right? And you just do that. Does this make sense? So this is relevant because first of all, you are typing commands in order for actions to happen. We already defined that. But sometimes you can't really set SetUID here unless you set it on there. However, in a program such as this, if you compile it and generate it, you know that you can make it root own and then SetUID. And now when you run this program, it could assume an effective ID of 0, but the advantage is you have the power to write the code in here. Got it? Is this idea clear? This is an important idea, actually. So I just want to make sure it's clear for everyone. So I will ask, are there any questions at this time about this, what I just said?
Nope.
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 All right, excellent. So too easy, too easy. All right, so now I think that's pretty much it. I've given the instructions for the lab. I went over, you know, the lecture notes. Just making sure I didn't miss anything. Remember again, one reminder, when you copy a program, even if you're in temp, if you just type passwd, it'll call the original program, not the copy that you have in there. For you to run the actual copy there, you have to say // okay? Passwd, and then it'll run that version, because otherwise the lab will be confusing to you, okay? So it's the local. All right, so just checking my notes. I think I'm done, but I want to make sure I didn't miss anything. A few other, I guess, notes. If you don't remember how to compile, you usually do GCC-O program, you know, the program name. So program, and then the actual C file, right? So program.c. All right, so that's how you compile. Giving you that. I talked about the symbolic links again. I'll remind you again, another thing you'll need is to remove a symbolic link, create another one, right? So RM/sh, you need to be in the folder where this is located. So you know, ls-l, right? And then you're gonna see, you know, you would see sh pointing to either bash, maybe dash, something like that. So then if you want to remove it, you type rmsh, and then if you want to create a new symbolic link to something else, then you do ln-s, and now let's say you're linking it to csh and sh. So this, once you type again ls-l, remember you're going to get now sh, which points to csh. So notice the difference between these two. Okay, guys? All right. And that is, so that should be it. Okay, so that concludes the discussion of this week's lab on the SetUID lab. I've given you the problems. You know what you have to do. This lab is due a week from today. So it's due Thursday by 10 p.m. On Tuesday, I will start discussing the new lab, which is called the format string, which has to do with memory issues, going back to the, the idea I did, I already talked a little bit about it. This idea, right? Talking about this idea of putting things in memory, reading things in memory. So that'll be next Tuesday. You can ask questions, of course, about the lab. And then, but that's basically the idea. So we're done with this week's lab, giving you all the materials, work on it. It's due on Thursday. And then next week, we'll start the next lab and so on. So, you get, with you guys, I can move fast. So, and we are going to do that because there's a lot of labs that we need to do this semester. Okay. So I have a question here. The -s means make it a symbolic link. That's what that means. So we're making a link, and that implies, and it's not a is it a -s? No, I thought it was just an s. It might be a -s. And that just means make it symbolic link. Okay? All right. Okay, great. So if there are no questions, or rather, I'll stay for a few minutes if you have any questions. Otherwise, we are done with today's discussion, and I will see you guys. Remember, this lab is assigned, and I will see you guys on Tuesday to start memory issues and format string and vulnerabilities. All right. So if you don't have any questions, you can sign off. Otherwise, just stay. I'll stay a few minutes just to answer your questions. All right. Have a good day and have a good weekend too.
Bye. Have a nice weekend, Professor.
All right. You too.
Bye.
Bye.
Hi, Professor. Are you here?
Yes.
Can you explain the symbolic link again? I'm sorry, I'm not very clear about this.
Yeah. So the symbolic link is let me go back to.
Have a look.
So a symbolic link in Linux, a symbolic link is whenever you do ls-l, right, on the terminal, it gives you a list of all the files, right?
Yes.
But sometimes you might have a file, let's say, this is the folder and there's another folder, and bash might be here, right, in another folder. And sh, which is not a file per se, it's just a name, might be in this folder. So one is you don't want to have this and then a copy of it. Instead, what you create is a symbolic link. So a symbolic link would be that sh points to bash. So literally, whenever you type sh in the terminal, you're really running that program.
Okay.
So that's what a symbolic link means. And so the convenient thing that we're doing is that in this lab, we might have bash, dash, CSH, different shells, interpreters. But whenever we run sh, we don't really want to care about which one we're running. We just run sh. And sh is a symbolic link to these programs.
Okay, maybe I got it.
Got it? All right, great.
Yes, okay, I will just know it in the net. No more thing I can.
Sure, no problem.
Okay, thank you. Have a good week.
You too. Have a good day. Bye-bye.
Bye.